All right, how we doing, everybody? Good. What happened to the rest of the class? Did everybody went to the party?
What party?
A fun party.
What's the what party?
I don't know. They're all partying somewhere.
I hope it's a tea party.
Maybe they're having a study party. They're like, we'll do
maybe it's a tea party.
Probably.
Nothing.
Anyways, everyone saw that the assignment's now due next Wednesday instead of this one day because the exam got pushed. You guys happy about that? Let me guess. Did anyone start the assignment? No, you guys are relying on that extra day. Ooh, I was going to start the assignment Monday now. I'm going to have 2 good days to actually do the assignment now, right? No, someone's going to still do it Monday or Wednesday, the morning of, or 2 hours before it's due. Don't do that, please. Or encourage you to start soon so that you can answer I can answer questions in class. That's the reason why, like, if someone has a question, give me a question, we will answer that. But this is a discussion course. All questions are asked. So, or just ask me whatever. That's literally what the point of this discussion is, to answer whatever you guys. So, any questions? What's up?
Oh yeah. So do we have to draw any direct form, direct block diagrams?
Did you read the assignment?
No, for the fourth exam.
For the fourth exam, yeah. Or I don't know. I really don't know what's on the exam. It's on total response, right?
Yeah.
You think you'll be having to do a block diagram? Did you master the first 3 exams? Or I don't know.
No.
They're all block diagrams, right? Did you guys have a block diagram on the third exam?
No.
No?
No.
Or yes?
There is.
On the third exam? Exam.
It's exam,
Yeah.
not program.
Okay. So, I don't know. Yeah, I really don't know. Anyways, but the exam will be on total response, and that's a sheet for later. Did you guys actually start? Actually, there's an error that I forgot. If anyone, only one person asked, which means they're doing the assignment. But the omega naught, I forgot to put the omega naught. It's the same one from the last assignment. So if you copy pasted the last assignment, you'll be not. This is the same. It's the same output. I'll tell you that's the answer. But the way we do it is going to be different because I'm asking for a ZSR. Okay. Determine the system's impulse response. Okay. Does everyone know how to do that already? Yes. So you have a whole system, correct? This is a building block. It's got zeros and poles, correct? Or feed forward and feedback problems, right? It's one big building block, correct? You kick the box, and what's the impulse response? You got to find the zeros, and you got to find the poles, and you're going to find H. Is that simple? What if I tell you this is actually your actual exam problem? Can you do this on the exam? Yes or no, maybe. Come on, y'all. I'm going to write this over here because I feel like someone's panicking. It's going to be the same thing again. Okay, whatever. I'll show you this, what I'm trying to do. You have some system, right? It's going to have, I don't know, y's are equal to x's, right? Stuff, right? And this right here is a whole h of n, right? And then within this system, right, we got y's and x's, right? This whole thing is going to be h of n, right? So that you can actually start solving for your problems is equal to h of n convolved with x of n. So now you're trying to build this. This is the biggest peak of the class, okay? We're finally doing h of n. We're solving for h of n. You've been given different types of h of n's. Now you're trying to design this or build this from scratch, all right? So are we familiar with what I'm trying to say? All right? Because this is going to be on the exam. He's going to throw you this exact same problem or something, and I want you guys to be able to follow, okay? All good? All right, anyways, let's see. How do I even solve for this? Impulse response, correct? I'm going to put a delta function into the input, right, and just see how the thing responds, correct? Right? And then let me just do a very basic block diagram. B0, I don't know. No. Put a D here, right? B1 plus. And this is A0 technically. A1 minus, okay. Don't forget the minus, okay. Y of n, correct? I'm gonna kick the block, right? Right, easy. And then let's just solve for C of n, right? When I throw a delta function into the feed forward block, what do I see at C of n? The delta functions, right? And whatever delays are there, right? Is that correct? Everyone understood how to do that? Can everyone solve for h of zeros? Is that good? Anyways. And then for our feedback path, right? Plus y of n. Wait, delta, there's a delta here. Or delay, sorry. A1 minus. Okay? Now if I put a delta function here, right? What does that mean for y of n is equal to 0?
Zero input response.
What does n equal? If I have a delta function at times n's equal to 0, what's going to be the output? 1.
Yes.
Right? Simple as that, right? And the 1's there. That's going to be your initial condition. Right? 1. Easy. Okay? But then the next one I'm going to tell you this is, let's just say, what if I have y is n equals to -1, correct? I'm just going to give you a number, just 0, correct? I'm just kicking the box. Is that understood with everybody? All right? So let's just start solving for stuff, okay? Show you that this isn't that bad. So I'm going to clear this screen. Let's see, how do I solve for h of zeros? Okay. Let's do this block diagram. R sine omega naught x of n minus 1. Let's take a piece by piece, okay? It's not hard, all right? I'm just having this, and it's just a system, all right? Is equal to C of n, right? Don't think too deep, okay? All right? What's the block diagram going to look like for this? Delay by 1, right? R sine omega naught, right? Or B of 1, correct? Plus over here. If I put a delta function here, right? And I'm trying to solve for h of zeros, right? What's h of zeros? Okay. C of n, right? Is equal to, I don't know, h of zeros, right? Of n convolved with x, right? And I put a delta function here, right? When I convolve anything with a delta function, what do I get? The ending, what?
Sorry.
When I convolve anything with the delta function, what do I get? You get the anything. Right?
Yeah.
Simple as that. So if I put a delta function here, right, I'm going to get this entire thing back. Right? R sine omega naught. Well, there's going to be a delta function over here. Xn minus 1. Is that understood? Correct? Easy? H of 0 is equal to this. Well, I'll tell you this. I don't know if I like this one right here. Actually, h of zeros is equal to this. This is a constant. There's that. Get the zeros back. Because I think what I'm trying to tell you, I'll show you later. Anyways, let's do the next one because this one's the one that matters the most. Yn minus 2r cosine omega naught yn minus 1 plus r squared yn minus 2 is equal to 0. And just put that right there. This is our second part, correct? All right. About to solve for our next part. The auxiliary equation, we're trying to solve for the feedback path zeros. We're trying to solve for h zeros. Is that or pole, sorry. Do we know how to solve this?
Yes.
How do we do that?
We first move everything towards the right side except for y. We solve for y.
We're trying to solve for an auxiliary equation, correct?
Oh, I know.
Right? Remember that from class? Auxiliary equations? So this y of n turns to what? Lambda, right? But we have a second order, correct? So that means we're going to have a lambda squared, right? Minus 2r cosine omega naught. And then we got this yn minus 1, right? You get a lambda naught to the 1th power. Easy. Plus r squared, right? And well, technically, this is kind of backwards. I'm just doing it the easy way, okay? This is technically 1 minus this to the negative lambda 1, right? Or to the lambda minus 1 power, right? And then minus 2 power and dot, dot, dot to the minus nth power, all right? To the delay, correct? I'm just doing it the easy way, okay? Because engineers like it easy, okay? What's the next step? Solve for the quadratics,
Yes.
all right? But let me tell you this. Has anyone read the actual impulse response or the total response book? Can someone tell me how we can lightning fast get this answer?
Don't you have to do something?
What do I do with that cosine?
You have to turn it into its linear. Yeah, because I saw it in the video.
Say it.
You have to turn it into its Euler.
Euler, yes.
Yeah.
That's the answer, okay? So if anyone's trying to do this the hard way and using like, what do you call it, trigonometry, you're not going to have a fun time. This class is going to be painful and hard. All right? So what do we remember about cosine? I don't know, omega naught is equal to e to the j omega naught, positive frequency, correct? Plus e to the minus j omega naught, negative frequency, correct? All divided by 2. Easy stuff? Does that make life a lot easier instead of doing trigonometry? I hate trigonometry. That's why we teach you Euler. But we don't tell you Euler until you learn your trigonometry. Okay? Let's make this problem easier. So I'm going to replace this cosine, right? 2r, right? Let me just do this. I'm going to skip some steps. Tell me if you don't like it. E to the positive j omega naught, okay? Positive frequency. Actually, I'm going to erase that too. I'm going to skip some steps, all right? Minus r e to the negative j omega naught. I have the positive frequency, I have the negative frequency, correct? Because we're just dealing with a sinusoid or a cosinusoid. Does that make sense? And then there's a lambda in here, okay? Don't forget it. Plus r squared. All right, now we need our actual, what do you call it? Let me see, that was page 1, this is page 2. Now we actually need to pull out our algebra. Who remembers, what do you call it? An easier way of solving, or solving for lambda for this. We gotta separate them, right? Find the common terms and try to, what do you call it, factor out, right? Because we're gonna get 2 solutions, all right? So we know there's a lambda here, right? Let me show you what I'm trying to do. So I'm going to put 2 big parentheses, okay? All right? The first one's going to be a lambda, correct? And then there's going to be an r here, right? Because we have an r squared term in there. I'm just going to put right there. So there's going to be a lambda there if I factor out the lambdas, correct? But now I got to figure out what the stuff in the middle is, correct? So I'll tell you this. We have a minus here, right? But we have a positive, right? What does that mean for the second term or for this part right here? Or this term right here? It's going to be negative, right? So because 2 negatives make a positive, right? Let me just put that right there, right? All right, what's our next thing? we got to have our actual, what do you call it, e to the j omegas, correct? Just going to put e to the positive j omega, correct? Is that easy? Now factor that back into that. Do we get the same answer?
Yes.
Yes? Easy? All right, we're getting this? So what are our answers? R e to the positive j omega, and then r e to the minus j omega. Boom. You're done, right? But now how do you use this? Remember the general equation we just solved for? Or we're trying to solve for? We're trying to solve for a general equation, our poles. So y, I don't know, poles of n, right? And we're going to have two general equations. C1 of lambda 1 to the nth power, correct? Plus C2 lambda 2 to the nth power. Does this look familiar? Yes?
Yes.
No? Maybe? He went over this in class, correct? Yes? He did. Right? I'm going to be shocked if you guys don't get this, okay? Replace our lambda 1, all right? C1. Then we got, I want to skip steps, I'm going to skip steps. Rn e to the positive j omega n, okay? I'm putting this positive for a reason, to tell you that these are frequencies, okay? A positive component and a negative component for your full, well, that's a hint for 2 weeks from now. We're going to have frequencies, all right? And plus C2 Rn e to the minus j omega n. Is that good with everybody? Boom, you're almost there. But now we got to solve for C1 and C2, okay? And I'm just going to do this for fun. Bipoles. All right? What's the first thing I just told you? What's our initial condition? At n is equal to 0. It's going to equal 1, correct? It's equal to C1. Then, well, you have r to the 0th is 1. E to the 0th is 1, right? Like skipping steps? Easy, right? Okay? And then, let's see. I'm just going to do C1 is equal to 1 minus C2. Boom, done, right? And now, I'm going to put in yp of n is equal to minus 1, correct? Because that's the initial condition I gave you right here. Right? Anything less than that is 0. Is that understood? So anything, if n is equal to minus 1, right? 0. Cool? Everybody following, right? So that's equal to, let's do, let me see, C1 r minus 1 e to the minus j omega, right? Plus C2 r minus 1 e to the, what do you call it? To the positive j omega. Is that good with everybody? All right, and then I gotta punch this guy back in there because I'm trying, actually, I'm gonna punch this guy in there, or do I want to solve for this one? What do you want to do? What's gonna make our life easier? Let's just punch this guy in here. Okay, this is all for the homework, okay? Everyone's gonna ace this homework, correct? We're all gonna get hundreds. Actually, where's my piece of paper? Go. So I'm going to do this. 0 is equal to C1 r minus 1 e to the minus j omega plus C2 r minus 1 e to the positive j omega. Now they flipped. Have you noticed that? The minuses and the plus flipped. That's pretty cool, right? But anyways, I want to substitute C1 is equal to 1 minus C2, correct? So now let's just do this. I'm going to skip a lot of steps right now. C1 r minus 1 e to the minus j omega, correct? I'm punching this 1, right? Minus C2 r minus 1 e to the minus j omega, right? Is that good? plus C2 R minus 1 e to the positive j omega. Cool? Let me see what I can do here. Okay, I think I'm going to do the following. I don't like this. Let me see. R minus 1 e to the minus j omega. Plus C2 R minus 1. Okay? Watch what I'm trying to do. E to the positive j omega, right? Minus e to the minus j omega, okay? Is that good with everybody? And I got this R1 there, I got this other R1 there. I'm not gonna like this one. But let's see what happens. Minus R minus 1 e to the minus j omega is equal to C2 R minus 1. Okay, I think things are gonna come out pretty good. Plus j omega minus e to the minus j omega. All right, we're getting there. Then you start seeing some, what do you call it? This term right here cancels out, correct, with this guy? Is that good? Then, let's see. I'm trying to see what I want to do. Is anyone bothered if I do this? C2, correct, is equal to minus e to the minus j omega over e to the positive j omega minus e to the minus j omega. Is anyone bothered by what I just did there? So I'm solving for C2, okay? And then I just divided this down here, right? There's the minus sign, correct? And I kept that there. Is that good with everybody? Now, anyways, let's see. How do I want to solve this? So we want it to be a little simpler. Because the other thing we can try to do... do I want to show you that? I don't know if I want to show you that one. C2. Because there's a better way to simplify this. Because what I'm trying to think about is if I just multiply the top and the bottom by 2, you can get a sign right here. So if I do this, 2, I don't want to do that. 2j divided by 2j, right? Because now I have this right here, a positive frequency and a negative frequency, subtracted differences, divided by, or with a 2j, correct? What does that give you? E to the minus j omega, right? I'm going to put this 2j right there, right? And then 1 over sine omega. See what I'm trying to do there? I'm trying to set this up, okay? Yeah, this is getting pretty tough. Anyways. I want to keep this. Let's roll with it. Okay? Now let me get my C1s. C1 is equal to 1 minus C2, right? And I just said that C2 is equal to 1 minus e to the j omega, right? All divided by 2j sine omega naught. Oh god, this is going to be tough. Let's see. I don't want to solve for this. Because I'm not liking how this is going. Let me see. Something tells me I did something here. Let me see. Let's check the solution guide. You guys happy that there's a solution guide? Look at this, okay? This is your guys' course, okay? Go to notes, right? Total response. The answer is right here to the assignment. Where do you guys think I'm getting your homework? Let me see. Where is our answer? Total response of a linear constant coefficient. Let's see, there it is. Total causal response. Y of n minus 2r cosine. Look at that. Just a different input, correct? But this is what we're trying to solve for. The zero, what do you call it? The poles of this, right? Let's see if I did it right. This is ZIR, right? But we're looking for ZSR, right? That's why I put ZSR right there, right? Was that a good hint? So let's go to ZSR. Oh, you see? Like that?
Convolution.
Yep. Zeros and poles. Do you think I'm pulling this like random? No, it's from his homework or from his notes. All right, you solve for the zeros. Look at that. There's your answer for your zeros. Am I making this class too hard? Or I don't know. I'm not doing anything. I'm not running the lectures. Just change your delta to that. Easy, right? And let's look at the proof. Oh, look at that. Look at those same initial conditions. Am I lying to you guys? This is literally your solution. So why am I saying this? Are we gonna all the assignments are doable. They're all uploaded on the notes. If you read through them, everything's given to you. So look at that. Oh, did I do it right? Is that right? Shoes. Come on, guys. Let's see. C2 and then C2. We did it right.
Oh, yeah.
This is gonna be on the final. This is gonna be on exam 4, by the way. Okay, memorize it. So that means C1 right there. I'm gonna skip some steps because I want to get this done. Anyways, how do I want to solve for this one? Because does he even solve for it here? No, because he expects you to do it for you. See how he skipped the steps? So this is the part you need to solve for. We just did that in class right now. You like that? But people want me to finish this problem, correct? Let's see, C1 is equal to, let me just do this. This is going to bother me, but 2j sine omega naught, right? Plus, what do you call it? E to the minus j omega, correct? And this is all divided by no, this is gonna suck. Don't do this. I don't like this. Remember how C2, or I'm gonna go back. Remember this little really nice equation right here? Remember how C2 is just equal to this? Right? Is everyone okay? Everyone knows that this right here is our answer, right? I'm gonna go back a step, right? And this is what I want, okay? I'm gonna copy paste this over here. Okay, that's our C2, right? C1 is equal to 1 minus e to the minus j omega over e to the positive j omega minus e to the minus j omega. Is that good with everybody? Okay, now this makes the math a lot easier. So I'm going to multiply this part right here to over here to this 1 to get e to the positive plus j omega minus e to the minus j omega, and then minus e to the minus, wait, no. Okay, this turns into plus, okay? And this is plus, okay, e to the minus j omega. Whew, so many things. E to the plus j omega minus e to the minus j omega. Man, there's so many omegas in this here, right?
Yeah. What is it?
Right? Got a negative frequency, right? And they cancel out. What happens? E to the positive j omega, right? E to the plus j omega minus e to the minus j omega, right? But you notice we have a difference right here, correct? When we have a difference in two frequencies, positive and negative, what do? 2j over 2j, good? To give us, what do you call it? Sine omega naught. And this is 1, and then e to the positive j omega over 2j. Is that cool with everybody? AKA this right here. Boom. Easy. Anyways, page 5. Let me just do the next page. Page 6. Okay. So I'm going to do the following. You tell me if I'm wrong. Let's see. Basically, this right here is your zero input or zero state response. It's your guys' answer. Is everyone clear with what I'm trying to show you guys? And for everyone watching from home, that all the answers are given to you. All right. So I'm gonna paper this. Remember this right here, right? That's our C1, C2. All right. Someone wants me to show you that. Y poles is equal to C1 lambda of n, right? Plus C2 lambda of n, right? Is equal to, what was C1? Is that ugly equation? It was e to the positive j omega over sine omega naught 2j, right? And then lambda was this guy we found in the beginning. Okay, a positive frequency. Rn e to the j omega n. Is that good? Then our C2 is going to be equal to, call it, minus e to the minus j omega over 2j sine omega naught Rn e to the minus j omega n. Oh God, that was painful, right? Anyways, there's some factoring we can do here. R of n, right? We got two common terms right here, 1 and 2. And then let's see what else we have. We have this 2j sine omega naught. And then I'm going to have, e to the, I got it. Okay, e to the positive j omega n. Or no, not n. Okay, e to the minus j omega n. Hold up. We got this. J omega n. Let me see. E to the j omega. I don't like this. E to the minus j omega. E to the minus j omega n. You see this 2j right here? You can combine it with one of these guys over here. But let me see. Look at that. How does he do it? Rn e to the j omega n. He keeps the ends together. How'd you get from here to here? Let's see. Oh, I know what he did. Let me show you. So you see this right here, right? We can combine this, correct? To be e to the j, what do you call it? Because we have another one, n j omega, right? N plus 1. Is that clear with everybody?
Yes.
Minus e to the minus j omega n plus 1. Right? Okay? So I'm going to rewrite it again. Equals R of n over sine omega naught, correct? Times 2j in the bottom right, times e to the j omega n plus 1, right? Minus e to the minus j omega n plus 1, right? Good? We have this 2j and we have this difference in two frequencies. What does that mean? Sine, right?
Yeah,
So this can turn into sine. Rn sine of, what do you call it? Omega n plus 1 sine omega naught. Did I do it right? Let me see. Hope I didn't. Hope I did. Yeah, there we go. All right. But then there's one last thing. He's going to dock you 5 points for this. Have you guys been forgetting your unit steps? He's going to dock you 5 points. He told me that. I'm playing. I don't know. At least a point. I don't know. Poles. Done, right? So let's go back to our page 7. Page 7. H poles is equal to Rn sine omega n plus 1 over sine omega naught U of n, right? That's our company B, feedback. H zeros is equal to of n is equal to, let's go back to the way beginning. See, that's page 2. Yes, let's see. I believe you, but I want to find my note. Go back to my thing. R sine omega naught, and then the delta function. R sine omega naught, and the delta function n minus 1. We have our two companies, right? Company A, company B, feed forward, feed back. H of n, right, is equal to H of zeros. Convolve with H of poles. Is everyone getting this?
Yes.
And all you got to do is just convolve. Well, you have this, convolving the anything with this. So I think what's going to happen, let me show you this. Wonder if there's an easier way of showing you this. Let's see what the book says, because I want to actually start doing some MATLAB. Zeros, poles, correct? That's your zeros, that's your poles. What happens here? That pops in here. That pops in there. You literally get the anything back. So let me show you this. Does everyone agree that this one here is a constant? Right? It's a constant, correct? And this right here is just our function, right? But we have this delta function, right? It's shifted by minus 1. So what does that mean for our actual total response? So we're going to just shift this right here, right? Shifted by minus 1. We're going to subtract the 1 here and 1 right there, right? Who's ready for the answer? Actually, and then we have this R right here, right? All the n's get shifted by minus 1, right? All right? So that means H of n is equal to R of n minus 1, right? Sine omega n, right? And then let me see. Okay. Sine, I'm just gonna write everything because I see some funny things. Okay, that's this part right here, right? And then U of n minus 1, correct? But then I got this term right here too, times R sine omega naught. Is that good with everybody? Okay, everyone's following? I got this R right here, right? And then I got this R right here, right? They combine to give you what? Rn, right? And then I got this term right here and this term right here. They're the same, right?
Yes.
So they cancel out, correct? Boom, that's the answer to your homework. Was that hard? So does everyone use this function in their MATLABs? Why do you think I told this was, well, okay, other than the brutal mathematics, is this going to be a 20-minute assignment? So now that you know, you solved, the reason why problem 1's asking you solve for your zeros and poles is so that, boom, you can do the following. Let me see. Well, this is something I was trying to do. Let me show you this. H of I is equal to R dot power I dot times sine omega 0 dot times I, and then you need the unit step. Units dot times the unit step of I minus 1. And that's it. And then if I think about it, this is H is right here. So let me tell you this. We have a delay in here, right? That's going to be annoying. Actually, let me see. Hold up. Because you can create this. U of 1, right, is equal to n when it's greater than or equal to 1, correct? Is that easy? But then I need to multiply this with this. So that means, and it should run. I'm just going to put a minus. Figure 1, stem, or no, subplot. What did I ask you guys to do? You need to generate 4 plots on one page where the first plot is the delta function. Okay. 1, we're going to generate 4, 2 by 2, correct? Or 1 by 4, I don't know. Actually, let's do a 4 by 1, right? And then stem, our time, and x, which is our input. Okay? And then, let's run this. Check for missing or extra characters. What happened? U of I minus, oh, no, it doesn't like that. U of 1, there you go. Boom. Missing characters, what happened? Oh, there you go. Pi divided by 7. Boom. The left and right sides have different number of elements, so we're calculating the ith point. Oh, no. R of n. R is a value. R of n. Okay. R to the ith. Omega naught times I. Give me a second, y'all. I think this was correct. Array index, okay. Maybe if I just subtract this guy. Okay. What happened here? This guy right here is should be a point. Evaluate, 0.99. This right here should also be a point, correct? Evaluate, a number. And this should be a point. Oh, U of 1, I minus 1. What's I equal to? What is I? I is equal to 1. Oh, it doesn't like this function. So what is our beginning? N begin. We're going to begin at minus 1. There we go. Boom. So I've created some powerful code. And let me see. I want to get the delta function over here. Let me see. I'm going to show you guys a way to make some powerful code. Okay. So I'm going to have a zeros, 1, 2, n beginning, right? Then I'm going to have a 1 right here. Okay. Is everyone understanding what I'm trying to do here? So I'm going to have some time, right? I'm going to have some like delays, correct? I'm going to have y minus 1, right? Or n is equal to minus 1, correct? So I'm just saying my time begins at n minus 1, right? N is equal to minus 1. For the delta function, I'm going to have at least 1, 0, right? At n is equal to minus 1, right? N begin. I'm going to put absolute value. Does everyone understand what I'm trying to do here? I'm adding 1, 0 right here. F9, correct? Right? So what happens if I started at n is equal to minus 2, right? Let me show you what I'm trying to do, okay? Here's my time, right? Beginning time to the end time, right? I'm going to go from minus 2 to 50, right? If I were to do the following, right? If I were to run this, F9, right? I start at minus 2, correct? Minus 1, 0, all the way to 50, right? Time is equal to 50, right? Is everyone understanding what I'm trying to do? So what happens to the 0 when I have that like minus 2 condition? I get 2 zeros, right? Then at 0, I want a 1. Is that understood? Then I got to finish out the rest, right? To the end, right? Abs of n, end, right? I have 50, right? But how do I make sure, okay, this is 0, right? And I want this to stop at 50, right? So let me see. How big was this? This was 1 by 53, right? So that means x has got to be 1 by 53, right? So we got 2 zeros, right? And we have 1, 1, right? That's 3 elements, right? So now we need 50 more zeros, correct? If n is equal to 50, right? We're done, right? Generate F9. Boom. Is x 53? Yeah. All right. Now we can actually run our thing. And because I'm too lazy, I'm going to do the following. Length of x. Oh, wait, no. Hold up. 0 is 1 length of x. Not that bad, right? Let's run this puppy. Woo! Look at that. Delta function. Easy. But technically, we don't need that delay. We want to put a minus 1 right here, right? Because we have that un minus 1, right? We have a delay, correct? Anytime you have a delay, you need to have some negative values for n, all right? And that's exactly what I did right here, okay? I'm accounting for the negatives at the beginning, correct? Because I need to push everything to the front, all right? I pushed it by 1, 1, right? And then I put a plus 1. Do you know why I put a plus 1? Because, what do you call it? N of 0 doesn't exist in MATLAB. You have to do n of 1, all right? Then you just copy paste this, boom, right here. And why did I not include the plus 1 over here? Actually, let's just put the plus 1, see if that still works. Oh, yes, it does still work. Is that good with everybody? Is that clear? Let's see. Title, delta function. Is that clear? And then you guys are going to make these pretty, correct? So I'm going to tell this right now. If the grader doesn't see labeled plots to subtract some points, all right? Stem n of h, correct? But I want to do this for subplot 4, 1, 2. Title, h of n when r is equal to 0.99. Look at that. Does that make sense? So you tell me. That's the answer for that one. Well, you tell me. When n is equal to 0, right? Nothing happens here, right? Because, well, we got to wait until n is equal to 1, right? Okay? When n is finally equal to 1, right, we're going to have some type of value, omega. This is going to be sine pi over 7 of 1, right? And then r of whatever that is, correct? Is that what we get right here? Something happened here. Something's wrong. You know what I'm thinking? I think it's because I did something funny with this one right here. So what's going on? What did I just do? So what I just did was, you know this u of 1, right? The u of 1 was already delayed right here, correct? I delayed it, right? I forced it, right? But I'm delaying it again. So technically it should be this. Is that understood? But I already delayed it. So there's two. You see, this is why MATLAB is very beautiful. You can do very different ways of control Y, control Y, control there we go. You can do this right here, but you have to assume that you're using u of 0, okay? Is that understood? Now it starts correctly. Do you see why I'm telling you to do your hand calcs to understand what's truly going on? Good. Answer to problem 1's done. What about Schwarz inequality? You guys remember that guy? Yeah? He's a happy, funny feller. Let me see. He says you got to do this and tell me when if it's stable or not. So if you want, you can try the following. You put this right here. Let me see. Boom, boom. Let me see. R of k sine omega not of call it not R of k. Hold up. Let me see. R of k and then u of n minus k of x of n minus k, correct? Is that good with everybody, right? But we want this one to be a bounded equation, great? Is that what it is? Or actually, let me show you this. Using the Schwarz inequality, we're going to squeeze everything into the actual summation. Remember that? Right? So then you're going to get the following. From infinity to minus infinity of r of k sine of u of k, right? Right? And then the unit step of n minus k, right? Then x of k, or n minus k, right? Remember that? Oh, sorry. Remember this? We start absolute valuing this, then you start analyzing this, right? What happens to sine? It's always going to bounce. It's going to always be less than 1. It's not going to explode, correct? Then this unit step also won't explode, and then your input also won't explode, correct? What's the thing that's going to explode? R of k, right? So that means what happens when R of k is 1? It's going to be bounded, right? 1 to the power of infinity is 1, right? What about if it's 0.99? It's going to, 0.99 to the infinity, right, is eventually going to go to a small number, right? And what about 1.01, right? That's going to blow up. Boom, you proved it. All right? Problem 2 done. Problem 3. We already did part 1. Do part 2 and part 3. I don't know. 1. Done. I'm already, you see? 0.01. Well, you won't see it blow up here. But let's just do 500. Don't do that. There you go. Easy? Is that what the assignment asked for? Calculate the first how many points? 51 points? Just prove to me that you can actually do this. And don't forget to comment. Boom. Okay? 0.01. Then let's try the next problem. Let's see. Using your program, correct? Now you have to put initial conditions, all right? So what does this mean about 0 input? Set x to 0. Cool. But now you got to start manipulating your h. All right? And boom, you get this done. Correct? What about problem 5? Now you start manipulating h and x. What about problem 6? Just add h of whatever you did from example 4 plus 5 equals 6. All right? And then example 6 is you're literally going to do this. I don't know. What do you call it? Total is going to equal h what do you call it? Y total response is equal to y ZIR plus y of ZSR. And that's pretty much it. Was that a 20-minute assignment? Well, not really if you knew what was going on, right? But you guys can definitely get this done tonight. Is that understood with everybody? Was this assignment? So what do you guys think about it? Pretty cool, right? So definitely read the textbook. This problem may be a potential exam question. And I'll tell you this, here's a hint. You can literally assign any of these other problems. Here's the time domain. Actually, you know what I think he's going to give you? He's probably going to give you one of these. He's probably going to give you this. Solve this, okay? The reason why we don't solve for this in MATLAB is because this is a time domain. Or not time domain, this is analog. MATLAB assumes digital, so that's why we're doing sampling. N-1, right? Instead of derivatives, okay? So I think your exam is going to be this. I think it's literally going to be this. I'm 100%. Total response. Actually, never mind. I think it could be one of these guys. I don't know. But anyways, this is probably the answers to something. Okay? So any questions about that? Exams next Wednesday, correct? And then let me see. I'll upload this again. Yeah, literally, yeah, that's it. Just manipulate this. This right here is the total response. This right here is a 0 input response. This right here is a 0 output response. Yeah. So that is nothing else to say. So other than that, this right here is the final pinnacle of the class where you guys are finally doing the last convolutions before we enter the Laplace transform. So how's that Laplace transform going? Fun? Painful? Next Wednesday, we're going to start hammering down the Laplace transforms, all right? And then depending on where he leaves over, I'll probably teach the remaining part. We're probably going to do it the easier way or something like that. Actually, Laplace is easier. Any other questions? No? All right. Have a good day, everybody.